Hello everyone, welcome back. Hope you all are doing well today. So in this video we are going to do exercise 6.2 of triangles. We have already done basic proportionality theorem and converse of basic proportionality theorem. So that concept we are going to use in this exercise, and if you have not seen the video, I have shared a link in the description. You can check out that video also. So once you see basic proportionality theorem and its converse, you can start with this exercise. So now without wasting any further time, let's start with the exercise. So in first question, two parts are there. One part I will do with you and the second one you have to try yourself, because this is very simple. It is given that the line DE, see this line DE, it is parallel to BC, and we have to find EC. See, we have been given AD, DB, AE and EC we have to find. So in this type of questions I have already told you, so you have to start by writing what is given to you. So given is DE is parallel to BC, and you can write the values of AD, BD and AE because these things are given to us. Now we have to, because here we have to find, so let's write it down what we have to find here. We have to find the value of EC. So let's do the solution now. So this, it is given this line is parallel to BC, and if you have seen and if you have already gone through basic proportionality theorem, it's given if any line in a triangle like this, it is parallel to third side of the triangle. See, these are the two sides of the triangle AB and AC. This line is parallel to third side of the triangle. So then the other two sides of the triangle, they are in the same ratio. So let's write it down. Since DE is parallel to BC, therefore AD upon BD, it is equals to AE upon EC. So why is that so? We have already learnt in a basic proportionality theorem, if a line is parallel to third side of a triangle, then the other two sides of a triangle, they are in the same ratio. So that's what we have written in ratio form. We have written. Now here you have to mention the reason also. According to BPT you can write basic proportionality theorem. Now we just have to fill the values of AD, BD, AE and EC we have to find. So AD, it is 1.5 centimeter. BD, it is 3 centimeter. AE 1 centimeter. And EC we have to find. So we'll just do cross multiplication because we have to find EC. So we'll do cross multiplication. If we do it, we will get EC into 1.5. See, we are just shifting. If you see in this way also, EC is, it is getting divided this side. If you are changing its side, it will get multiplied. Same way 3, it is getting divided this side. So if you are changing the side, it will get multiplied. So this 3 will be multiplied with 1. Directly cross multiplication also, it will suggest us the same thing, and if you are changing the sides, if you want to do in that way, both mean same. Now EC into 1.5 is equals to 3 into 1. Now we need to find the value of EC. So just keep EC on this side. So keep EC on this side and shift 1.5 to other side. So 3 into 1, it will be 3. And 1.5, it is getting multiplied with EC on this side. So if you are changing the side, this 1.5, it will get divided by 3. So EC is equals to 3 upon 1.5. So now this 1.5, just remove the decimal. If we are removing decimal, so here we have to multiply this with 10. We just removed the decimal and we have to write 10 over there. Now we get 3 into 10, it is 30 upon 15 because we have removed the decimal, so now it is 15 instead of 1.5. See, whenever you are removing decimal, if you remove decimal in denominator, if it is in numerator the term, then you have to write this value in denominator. If the term is in denominator, you have to write it in numerator. So the only number of zeros will be same how many digits you have after the decimal. If you have 1.52, like 2 digits are there after the decimal, 1.51 for example, so you have to write 100. So it depends how many digits you have after the decimal. So if the term is in numerator, you have to write this term in denominator. If the term is in denominator, you have to write this term in numerator. So that's what we have done just now. Now we can do cancellation. 15 into 1 is 15 and 15 into 2 is 30. So EC will be equals to 2 centimeter. So the concept, it is very simple, basic proportionality theorem. That result we have applied, that if this line is parallel to the third side of the triangle, then these two sides, they are in same ratio. So this same concept you have to apply in part second also and find the value of the given side. So I want you guys to try it and post your answers in the comment section. Now let's do the next question. Now let's start the second question. So E and F are the points on sides PQ and PR respectively of triangle PQR. For each of the following, state whether EF is parallel to QR. So we have to draw figure first. 3 parts are there, 2 will discuss here and 1 you have to try yourself. See, we have to draw triangle PQR. So let's name it PQ and R. E and F. See, whenever you have to draw a figure yourself, just go through the statement twice or thrice so that all the points, they are correct. Now they have mentioned E and F are the points on side PQ and PR. So we have to see PQ and PR sides and we have to draw these points. Here it's written respectively, which means E is a point on PQ. So let's mention it, E point, and F, it is a point on PR. So here we will mention F. So we can join this. So this is the given triangle and we have to prove that, or we have to state, we don't have to prove anything, we have to state whether EF it is parallel to QR or not. So let's see. If we see first part, let's write down all the values. PE it is equals to 3.9 centimeter. EQ it is equals to 3 centimeter. See, all the values I have already written. PF it is 3.6 centimeter and FR it is 2.4 centimeter. So in the converse of basic proportionality theorem, we have already learnt if the sides they are in equal ratio, then this line it will be parallel to this line. See, it is completely opposite of basic proportionality theorem. In basic proportionality theorem, it was given that this line it is parallel to this line, but here in converse theorem it is given that if the sides they are in equal ratio, they are in same ratio, then this side will be parallel to this. So let's find it out now. So again, same way you have to start in this way. First of all, write the given things, then write what you have to find, then start with the solution. So let's check the ratio. PE upon EQ, we can write if PE upon EQ is equals to PF upon RF or FR, we can write anything. Both mean same, whether if you write FR or RF, both mean same. So if the ratio is same, then EF it will be parallel to QR. So this reason you can mention converse of BPT. BPT is basic proportionality theorem. So this way you can mention the reason. Only one thing you have to remember in both the theorems. In BPT it is already given that these lines are parallel, but in converse it is not given. In converse this thing is given to you. Now let's write the values. PE it is 3.9, EQ 3, 3.6 and 2.4. I have just written the values of PE, EQ, PF and FR, which are already given to us. You can see. Now let's do the cancellation. So same way, if you remove, see this side we will solve individually and this side we will solve individually, because we have to check whether they both are equal or not. Don't do any cross multiplication or any changing of side. Individually you have to check. So let's do. So if you remove this decimal, here 10 will come. I have already told you if the number is in numerator, this number will come in the denominator. So we have removed decimal from here. So we got this. Now 3 into 1 is 3. 3 into 13. So we got 13 by 10. This side we can write 13 by 10. So let's solve this side. This decimal and this decimal, they will get cancelled. So why they will get cancelled? So if you cancel, if you remove this decimal, you have to write 10 over here, and if you remove this decimal you have to write 10 over here. See, from numerator if you are removing decimal, this number will come in denominator, and from denominator if you are removing decimal, this number will come in numerator. So this and this will get cancelled. Now we can do its cancellation. We can see 36 and 24, both they are coming on 6 table. So 6 into 6 is 36, 6 into 4 is 24. Again on 2's table we can do cancellation, 3 into 2 and 2 into 2. So I got 3 by 2. So on left hand side you are getting 13 by 10, and on right hand side you are getting 3 by 2, which are not equal. Since the ratios, they are not equal, which means these lines are not parallel to each other. Now let's see for this part, second part. Only the values we have to substitute accordingly. Figure will remain same. So PE it is 4 centimeter, QE it is 4.5 centimeter, PF it is 8 centimeter, RF it is 9 centimeter. PE4 we will just have to substitute the values. EQ 4.5, PF 8 centimeter and RF or FR it is 9. So individually we have to solve left hand side and right hand side. This decimal if we remove, we have to write 10 in the denominator, because only one digit was there after decimal. That's why we have written 10. Now let's see if any cancellation is possible. If you multiply 4 into 10, it will be 40. Now you can see 40 and 45, they can be cancelled on 5's table. 5 into 8 is 40 and 5 into 9 is 45. So you got 8 by 9. So this side also it is 8 by 9. So since the ratios are same, which means according to converse of BPT, converse of basic proportionality theorem, EF is parallel to QR. You just have to remember, if the ratios are same, then this line it will be parallel to this line. Now let's do the next question. In the third question, this figure is given to you and you have to prove this thing. AM upon AB, AM upon AB, it is equals to AN upon AD. So what is given to you? Same way we will write that thing first. Always in questions of geometry, whenever you are doing any proofs, see we have to prove this thing. So better to write each and everything step by step. First of all write the given thing, then what you have to prove, and then proof. Same way like we have done proof of theorem also, same way you have to do. So what is given? You have been given LM, it is parallel to CB. This LM it is parallel to CB. And Ln it is parallel to CD. Ln it is parallel to CD. So these two things are given to you. See, two triangles are there. While doing theorem also, I have explained you, whenever different triangles are there, draw rough sketch of single triangles, so that the results you can use it easily. So one triangle is ACB. So I will write in this way only, because see, you can see it is ACB. We won't write ABC. So ACB. So in ACB, this line is there, LM. Another triangle is ACD. So other sides ACD. On C, see these points you have to write very carefully. On AC you have point L. So L you will write on AC, and AD point N is there. So these two rough triangles from this figure I have drawn. Now this is already given to me that this line is parallel to this and this line is parallel to this. So directly we can use the result of basic proportionality theorem. When this line is parallel to third side of the triangle, the other two sides of the triangle, they will be in same ratio, or they are in same ratio according to basic proportionality theorem. So first of all, given thing we have written, and then to prove means this thing you can write AM upon AB, it is equals to AN upon AD. Then we'll start with the proof. So if you are doing any construction, then construction part also you can write. So proof we can write. So according to basic proportionality theorem, directly we can use the result in this triangle. Since LM it is parallel to CB, we can write in this triangle ACB or ABC, same thing. Since LM it is parallel to CB, this line is parallel to CB, therefore AL upon LC or CL, it is equals to AM upon BM. According to BPT you can write basic proportionality theorem. Theorem 6.1, which we have already done. Now let's mark it as point number 1. You can write this LN is parallel to CD. In this triangle you can write triangle ACD. So therefore AL upon LC, it is equals to AN upon DN or ND, same thing. So mark it second point. This is also because of basic proportionality theorem. So 2 points we have got. So if you observe carefully point number 1 and point number 2, you can see AL upon LC, it is equals to this term also, and AL upon LC, it is equals to this term also. See, if two terms they are equal to common term, which means they are also equals to one another. For example, if I say x is equals to 1 and y is also equals to 1. See, 1 is this common term, this one. So which automatically it means that x is equals to y, because both of them they are equal to 1. So whenever any term it is equal to one single term, then they both are equal to each other. Same thing we will apply here also. AL upon LC, it is equals to this also, AL upon LC, it is equals to this also, due to which AM upon BM, it is equals to AN upon DN. So you can write from 1 and 2. From 1 and 2, what we have got, AM upon BM, it is equals to AN upon DN. So you have to keep on looking what you need. We need AM upon AB, is equals to an upon ad. But if you see this term, we have got am and an, but we need ab and ad, not bm and dn. So what we will do, we'll do another step. So whichever terms you need, don't make any changes to those terms. We need am and an, but these two terms we don't need. So as of now, we'll do reciprocal of both the terms. Reciprocal of both the terms. You'll understand why we have to do. And one thing you always have to remember, whenever we are making any change in equation, we have to make that change for both the sides. For example, if I have this equation, a is equals to b. So if I have to add 1 in this, I have to add in both. So why in both? Because this one, if I shift to this side, it will be a plus 1 minus 1. This plus 1 will be changed to minus 1. So 1 and 1, plus 1 and minus 1, it will get cancelled. So I am left with a is equals to b, which was same as earlier. So that's why this, just I have explained you why we have to make changes on both sides of the equation, because if we make any change on both sides of the equation, it won't make any change. So do reciprocal of both sides. Reciprocal means we just have to reverse it. So it will become bm upon am equals to dn upon an. So reciprocal, I'm sure you know the meaning, just we are changing numerator and denominator, interchanging numerator and denominator. You can see am upon bm, I have written bm upon am, and an upon dm, I have written dn upon an. So reciprocal I have done. So now add 1. Add 1 on both sides. So in proofs, whatever way you feel like if you do this way, you will reach to this result. You can do whatever you want to do. It's like you are free to do anything. It should not be incorrect, but anything you can do. So add 1 on both sides, plus 1 plus 1. I have explained you any change means on both sides we have to do. So am, so we can now take LCM and we can solve it. So LCM of am and 1, it will be am. So it will be bm plus am. Simple LCM I have taken, and then if you take LCM, you will get this term, because LCM will get divided with both the terms. am divided by am, it will be 1 multiplied by bm, so it will be bm. Plus with 1 also, if you divide am, it will be am, so 1 into am. Same way you have to do this side also. Plus 1 means an will be the LCM of 1 and an, then it will be dn plus an. Same way, LCM you have to divide with the denominator and then you have to multiply with the numerator. The answer of this you have to multiply with the numerator. So I got this, bm plus am upon am. Now you just have to see this figure. See our terms bm plus am. If you see this figure, bm plus am. So if you are adding bm and am, you are getting complete ab. So we will just substitute the value now. ab, so here bm plus am, it is ab upon am, equals to, as it is, dn plus an. In this you have to see dn plus an. If you add these two, you will get complete ad. So you will write ad upon an. So now all the required terms you have got. You can see also am, ab, ab, am, an, ad. But the only thing is they are in reciprocal form. I mean they are in reverse form. So again you can do this step, reciprocal of both the sides. If you do reciprocal of both the sides, you will get am upon ab equals to an upon ad. So you got this. See all these steps, if you do practice, if you try to do these sums, if you try to do the proofs yourself, all these steps automatically you will know, like if I do this step, I will reach to this conclusion. So more practice means more ideas will come to your mind. Maybe you can do this by some other method, not this. So try to do practice also along with me, try to do yourself. If you are not getting, then just take my help. Now let's do the next part. In question number 4, this figure is given to us and let's see what we have to do and what is given. So writing same way, you have to write first given things. So two things are given to you, DE, it is parallel to AC, and DF, it is parallel to AE. So the given things we have already written, and now what we have to prove. So to prove, we can write BF upon FE is equals to BE upon EC. So here if you see, two triangles are there in this figure. One, they have mentioned that this side DF, it is parallel to AE. So I will take this triangle A, B and E. I have taken this triangle, see, A, B and E, in which DF, it is parallel to AE. So always try to draw rough sketch so that easily you can locate all the points. So one, this triangle ABE I have drawn, in which DF, it is parallel to AE. You just have to very careful, see, this point F is on BE. So point F should be on BE and point D, it should be on AB or BA. Now the another triangle which is given to us, from this we can see they have mentioned that DE, this one, DE, which is this one, it is parallel to AC, this, which means one, this full triangle I have to take ABC. So I have taken ABC, on which you can see the points. On AB we have D point, I have marked, and on BC I have E point. So I have marked accordingly. So while drawing rough sketch, all the points, it should be correctly mentioned like the way I have told you. Now again they have mentioned, or they have given something related to parallel lines. So parallel lines means figure is something like this, and the parallel lines have been given to us, due to which directly we can use BPT, basic proportionality theorem. So in this exercise, in all the questions, only two theorems you have to use, BPT and its converse. So just try to do this question yourself and pause this video and try to do it. So if you get any confusion between, you can just take my help. So let's start now. In proof, so we'll mention in triangle ABC. Any name you can, BAC also you can write, ABC, everything is same. So we can write in triangle ABC, DE, it is parallel to AC because it is given to us. So therefore BD upon AD, it is equals to BE upon EC. Why they are equal? Because of basic proportionality theorem. So in basic proportionality theorem, it's given if this line is parallel to this, then this line, it will divide the other two sides of the triangle in the same ratio. So that's what we have written now. So let's mark it point 1. Now let's write for the other triangle. In triangle BAE, DF is parallel to AE. It is given. So everything you have to mention properly. It is given. So therefore the other two sides of the triangle, they are in same ratio. BD upon AD, it is equals to BF upon FE. So mark it as point number 2. So if you see, or if you observe these 2 points carefully, you can see BD upon AD and BD upon AD. We have this term in both. So due to which, like we have already discussed in previous question also, if two terms they are same with a common term, then these two terms are also equal to one another. So you can directly mention from 1 and 2, from 1 and 2. See, because these two terms they are equal to common term BD upon AD, BD upon AD. So therefore BE upon EC, it is equal to BF upon FE. From 1 and 2 you can mention. Now if you see this thing, BF upon FE is equals to BE upon EC. So same thing we have got. So this sum was very easy. So in 2 steps C we have proved the result. Now let's do the next question. In question number 5th, this figure is given to us, and it's given to us DE, this DE, it is parallel to OQ, and DF, this DF, it is parallel to OR. So we have to show that EF, it is parallel to this EF, it is parallel to QR. See, very simple again. First of all, if any lines is given parallel like this, so it's very much sure that we can directly use BPT, basic proportionality theorem. So in this question also, if you want, you can draw rough sketch, but this is very clear, so directly also we can use the result, no need to draw the rough sketch. So same way you have to write what is given to you, what you have to prove, and then proof you can start. So I am directly starting the proof now. So first of all, I will take this triangle, so I will draw here so that you won't get confused. So this is like this. So here, so this is P, this point is E, D, O and Q. So POQ in triangle POQ, this one. Straight also if you want you can draw. So other triangle is POR. So I will draw straight triangle POR. So in this we have DF. So better to draw rough sketch. So in triangle POQ, it's given to us that DE, it is parallel to OQ. It's given, you can mention as it is. So if these lines are parallel to each other, we can use the result PE upon EQ, it is equals to PD upon DO. See, basic proportionality theorem, this over this, this over this, because the sides they are in same ratio. Because of basic proportionality theorem, if this line is parallel to this line, then the other two sides of the triangle they will be in same ratio. So that's what we have written. So first point. Now let's take other triangle. In triangle, other one is POR. It is given DF, it is parallel to OR. Parallel means again we can use basic proportionality theorem here. So if these lines are parallel to one another, the other two sides of the triangle they are in same ratio. So we can write PD upon DO, it is equals to PF upon FR or RF. So BPT is same, reason is same, basic proportionality theorem, and point second we can name it. Now you can see, if you see both of these equations, you can see PD upon DO is there in both. So same thing again we can apply here. If two terms they are equal to one same term or one common term, they are equal to each other, which means from 1 and 2 PE upon EQ, it is equals to PF upon FR. See, this term and this term they will be equal. Why? Because they both are equals to PD upon DO, PD upon DO. That's why they are same to one another. So now we have got this result. But what we have to show? We have to show that EF, this line, it is parallel to this. Now if you see the bigger triangle, I'll just draw this. Everything I will remove now because we have already done. So what you have to prove? This thing you have to show. Suppose only this triangle is there and you have to prove EF, it is parallel to QR. So if you see this triangle, now you can see PE upon EQ, it is equals to PF upon FR. Now we have done the other theorem also, converse of basic proportionality theorem. If the sides, they are in same ratio, then this and these two lines, they are parallel to each other. So you can write, if this is there, therefore EF is parallel to QR, and reason you can mention converse of basic proportionality theorem. See, if the sides of the triangle, they are in same ratio, then this side, this line, it is parallel to the third side of the triangle. This is according to the converse of basic proportionality theorem. So with this, your 5 questions of this exercise have been completed, and the next 5 questions from 6 to 10 I will continue in the next video. Thank you so much for watching the video.